evening, students. Who can remind us the previous topic we discussed together? Musime?
Thanks a lot. The previous unit is projectile and uniform circular motion.
Yeah, the unit we discussed is the projectile and the uniform circular motion. What does it mean, projectile? Cadnes?
Thank you. The projectile is an object that is thrown or projected forward into space by a force.
Thank you for a good definition of projectile motion. And also we have another keyword which is in that unity, which is uniform circular motion. Yeah, uniform circular means what? Divik?
Uniform circular motion is the movement or motion of a body along circular path within constant velocity.
Okay, thank you. Yeah, is anyone has a question about that topic? No one has a question for that topic? Okay. Yeah, if there's no one has a question about that topic, today we are going to discuss new topic. It's the topic number 9. Yeah, the topic number 9 is universe gravitational field potential. Yeah, please. For this one here, you see this word universe is repeating again also for this key unity competence. We must first know what does it mean universe, and also what does it mean gravitational field potential. But the keyword there is gravity. What do you understand by the term universe and the term gravity? Babla?
Thank you. What I understand by universe is that universe is a collection of different planets which includes also the Earth.
Yeah, can you come and write? Thank you, Babla. She defined universe as is composed by different heavy bodies, which include the Earth. Who has another definition for universe? Tito?
Thank you. I can define universe as a collection of different heavenly bodies, including time, space, and other continents. Thank you.
Anyone who has another definition, which is different for this one? By Ingana.
The universe is endless space, which contains heavenly bodies, including planets and stars.
Thank you for your definition, please. All of you are talking about the universe is composed by the planets, stars, and the other bodies, include us. Are you together? Yeah, and also we have another word, gravity. What do you think about this gravity? Flaha?
Gravity is the force exerted by the Earth that pulls an object toward the center of the Earth.
Go and write it now. Gravity is the force exerted by the Earth that pulls an object toward the center of the Earth. Yeah, I think that he is thinking about the Earth. Do you understand? But please remember, for the first definition of universe is made by different planets. Universe. Do you understand? Yeah. If now she talked about only the Earth, and also the other planet can exert this kind of force. Is anyone has a definition, another definition for gravity? Juvent.
I understand gravity as force of attraction between any two massive bodies.
Come and write it now. Yeah, thank you so much. Now I can combine all those two definitions, universe and gravity. Then by also focusing for our unity. The unit is known as universal gravitational field potential. Yeah, in this unit, we study the motion of the planets and also the force to hold those planets together. Yeah, the planet, they are moving. Why the planet, they are not moving away? They are at the fixed position. Are you together? Yeah, means what? In this unit, we study the motion of the planet and also the force to hold those planets together. Let us now start with this video. Then we are going to watch it. Then after, we discuss it in a group.
We saw that the gravitational force is the attractive force between any two objects with non-zero mass separated by a distance. So does the apple fall towards the earth, or does the earth move towards the apple? Or do both move towards each other? It's actually simple logic. This is the earth, and say this minuscule object is an apple. Based on what we learnt about the gravitational force, both apply an equal force to attract the other object towards itself. So if the forces are equal, which one will accelerate more? Based on the Newton's second law, we know that the force applied is the product of mass and acceleration. So the acceleration will equal force over the mass. The acceleration is inversely proportional to the mass. If the mass is more, the acceleration will be lesser. As the mass of the earth is much more than the mass of the apple, it is the apple that accelerates towards the earth and not the other way around. Hope that makes it clear. Now the question is, how do we quantify this force? To understand this, we need to understand a simple concept. And this simple concept is called the universal law of gravitation. Say there are two objects A and B separated by a distance d. The distance between the centers is considered the distance between the two objects and not this distance. Assume that the mass of object A is m1 and that of object B is m2. As object A is bigger, let's assume m1 to be bigger than m2. The universal law of gravitation says that every object in the universe attracts every object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Let me repeat. The force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. With this data, we can write it mathematically like this. So if the mass of any of the objects increases, the gravitational force will have more magnitude. And more the distance between the two objects, the lesser will be the gravitational force. Directly proportional to the product of the masses and inversely proportional to the square of the distance between them. This can be written as F equals G times m1 times m2 over d squared. G here is the constant of proportionality and is called the universal gravitational constant. The equation can be modified and written as G equals F times d squared over m1 times m2. The value of G was found out by Lord Henry Cavendish using a torsion balance. The universally accepted value of G is 6.673 times 10 raised to negative 11. What will be the units of G? Force is newtons. As the distance is in meters, we have meters squared. And as the mass is measured using kilograms, we multiply this with kilograms raised to negative 2. This is the value of the universal gravitational constant.
Let us now join our group of discussion and please answer the following questions. Yeah, you can choose a representative, then you can write the questions. Then on this flash disk, you will find a lab textbook for students. We are discussing. You finish question number 1? Question number 1. Yeah, questions? Yeah, all questions you can do it. We have weak force. Yes. We have a weak force between the Earth and the Moon. Yes. That's why the Earth is not falling on that one. say, gravitational force on the moon were moving in a perfect circle, the gravitational force will always be sideways. It's just cause it to number 2. Now number 1 it is over.
Yes.
Yeah. 5 minutes more. From those idea from unit number 8, you will find now the answer why the moon not falling on the earth. And also please focus also for Newton's first law, saying that the body will continue to move in its direction if there is no force acting on it. The moon is a object that moves in circular motion. Time is over. Let us now present those ideas. Yeah, I can start with group number 1 for first question. Group number 1.
This is group number 1. We discussed about the Newton's law of gravitation. We saw that everybody in the universe attracts each other with a force that is directly proportional to the product of their masses and inversely proportional to the square of distance between them.
Thank you so much. Then secretary can write for us. Thank you so much for first group. Then other group, please. Who can add more? Yes, group number 4.
Thank you. As they said, F is the force of attraction and G is the gravitational force. M1 is the mass of the body 1, which is greater than the M2, which is the mass of the object 2, and the D squared is the distance squared of between the two objects. Thank you.
This is the gravitational constant. Is any group has something to add for this one? Any group please has something to add for this one? For Newton's law of gravitation. Deborah?
What I can add is the value of the gravitational constant.
It is the value of the gravitational constant. Okay, thank you so much for all group. Please for those idea. Then let us go to next question. Write down the properties of gravitational force.
Thank you. We have been discussing about the gravity in the universe, and this question asks us the properties of the gravitational force. Firstly, the gravitational force is always attractive. As we have said that gravity is the force of attraction that pulls two massive objects towards each other. So it's always a force of attraction, unlike the electromagnetic, the magnetic forces that are always attractive and repulsive. Secondly, it acts towards the center of the Earth, or it acts towards the center of the massive bodies. As we have said that the gravitational force uses distance in the formula, as we have said in the law. And the distance between the two massive bodies that have been said are not the distance between the massive bodies physically, but it's the distance between the objects from the center of the masses. It's also the weakest force in nature. From the research in our group, we have seen that the nuclear force is bigger than the gravitational force. The gravitational force is radial. As we can explain this as that the further you move from the center of the Earth, or the further you move from the object which is pulling another, the more the gravitational force becomes less. It's a conservative force, which means that an object being acted upon by the gravitational force and the object is moving in a circular path, is the gravitational force, when it's calculated, it becomes 0. So that's why it is conservative. It also holds good over a wide range of distances. As we have seen that in the universe, there are many heavenly bodies and they attract each other. So that means that the gravitational force can not only act between two bodies that are on the Earth, but can also act between two bodies, two heavenly bodies like planets, which are millions and millions kilometers afar from each other. So thank you. This is what I have found in our group.
Yeah, thank you so much for this group. Please, for those good idea about the properties of gravitational force. Yeah, another group, please, has the idea about this one. Kaneza, add one idea for this one.
Thank you. Another idea, we found that it is an action-reaction pair. It means that as we have studied the Newton's laws of motion, the Newton's third law, it is an action-reaction. It means that if body A exerts a force on body B, then body B is also going to attract to exert an equal and opposite force to that body A. So I think that we've said that it is an action-reaction pair because the force which that one body is the Earth attracts the second body, which is the Moon. It is equal to the force which the Moon also acts on that body, which is the Earth. Thank you.
Please let us go to next question. Group number 5, please. They can present about this one.
Yeah, thank you. The third question is that if the gravitational force is attractive in nature, why is the Moon not falling on the Earth? Here, by basing on Newton's law of motion, there is a Newton's law of motion which states that every object persists in its state of rest or uniform motion in a straight line unless it is compared to change the state force impressed on it. This is the Newton or the law we based on finding the solution for this. The solution is that the Moon doesn't fall into the Earth by the gravity because it moves fast enough to avoid this. So instead of falling, it keeps on orbit around the Earth. If it is moved too slow, it would crash into the Earth. If it is too fast, it would escape into this. This is why the Moon doesn't fall onto the Earth, because it has a fast speed to maintain its rotation and the movement around its orbit, why it does not fall onto the Earth. Thank you.
Yeah. Thank you so much for your idea. I think the idea is clear. Now, please, the group, they can share those documents. Group number 4 to number 1, share those copies, please. Then they can read what you wrote it about that one. Yeah, this question number 5, it is the homework. Question number 4 is the homework. Question number 5 also, it is the homework. This question number 5 you will find in a lab student's book. Yeah, senior 4. Senior 4, physics. Yeah, page 337, question number 3. You will do this one as the homework. You will submit before starting also the other topic. Who can tell us the unit we discussed today? Ave?
Thank you. We have discussed about the Newton's law of gravitation, which states that every particle in the universe attracts every other particle with a force which is directly proportional to the product of their masses and inversely proportional to the square of the mean distance between them. We have also seen the properties of the gravitational force, which is it's always attractive in nature. It is a central force. It is a two-body interaction. It is also a conservative force, and it is an action-reaction force. Thank you.
Thank you so much. Please see you for next lesson.
We have learned about the universal gravitation field potential. What I have learned that are the different definitions in the universe and the gravity, and also the Newton's law of the universal gravitation force, which is that every object attracts each other with a force directly proportional to the product of their masses and inversely proportional to the square of the distance between them. And I've also seen about the gravitational force and their properties, like it's always attractive, it is a conservative force, it is a reaction and action force, and many others. I have seen that the Newton's law of gravitation help us to describe the uniform circular motion and also to launch the satellites in the space from the Earth. Thank you.
We've seen about Newton's law of gravitation. It can help us in many things, where like in airspaces, ships, and we saw that due to the mass, which as we've seen in the formula, that which is gravitational force times mass 1 times F2 over the distance squared, which is the law of gravitation. We've seen that it can help us in many things. That is the reason why all things that exist on the Earth's surface fall on it or come back to the ground. Thank you.
The methodology I use to teach this kind of lesson, it is a learner-centered method, where the learners must be the source of information, and a teacher guide them to have information about the lesson. The objective of this lesson is to help the learners to know about the motion of the planet and the force acting between those planets.